Hey guys, so this is number 4 from 2011. Oh, sorry, actually no, it's 2012. Okay, yeah, 2012. And so essentially we're going to go through this question, so let's get right into it. So this says, what are the contents of the topmost 3 bytes of the stack after the execution of the following code? So we start from the first line is origin 4000. So origin 4000 is going to correspond with the instruction length in bytes. So every line that I run, I'm going to add bytes to 4000. So for the first line, I'm adding 3 bytes to 4000, I'm adding 2 bytes to 4000, I'm adding another 2 bytes to 4000. And it actually stops at jump start register. And the reason why is because jump start register actually starts off the subroutine, which the subroutine will draw from whatever the previous lines were, and it's going to perform operations. So essentially, what's happening here is we're loading in things to the registers we're loading things into the registers in the stack, and then we're pushing A into it. Okay, and we're pushing A into the stack afterwards. And so, but the first thing with jump start routine, this is going to be the first thing, is because we're going to putting in $4000 all the way up, plus all the bytes up to that point into the stack first, and then we're going to do the subroutine, which is mel, and then push A is going to be the second thing. Okay, so let's start off from the top again. So 4000, we know it's going to be adding bytes. Okay, we got that. So we're going to load S pound 3000. That means we're loading the memory address of 3000 into the stack. S stands for stack. If you look into your code here, if you look into the manual, you'll see that stack pointer is the register. It's a 2-byte register. So in here, all the stack content will be 2 bytes. It will be in this case, sorry, it's 1 byte. My mistake. But it is a stack pointer, and it's only 1 byte. And the reason why it's 1 byte is because each individual bytes will go up by 1. So only one byte per one stack address. Jesus. Okay. So load S, load stack point of 3000. So we're going to put that on the bottom here. And this is a last in first out system, so everything that we put in is going to go from the top. Okay, and so when we want the topmost 3 bytes, we have to actually decrement this 3000 by 1 3 times. So this is going to be 2 F F F $2 F F E, and then $2 F F D. Okay, and so again, if you're wondering how I did that, it's just hex. So 1 to 9 is 1 to 9, 10 is A, 11 is B, 12 is C, 12 is C, 13 is D, 14 is E, and 15 is F. Okay, so we're starting from 16, which is 0 0, and then going back to 15, which is this, and then back 1, back 1, back 1, all the way here. Okay, and so alright, so that's load stack pointer at 3000. Okay, and we wanted the 3 most bytes. Second thing we need to do now is we're going to load A, accumulator A, with $32. So if I look into here, this is my accumulator A in the memory. This is the accumulator inside the memory, the registered memory. And what we're going to do is we're going to load accumulator A with $32. So this is going to become $32. Okay. Now we're going to do jump to subroutine. Jump to subroutine mel is the function that we're calling, right, or the subroutine that we're calling, and the subroutine inside executes push A. So for the first thing though, jump start routine mel, we have to put in the origin plus all the bytes up to the jump subroutine. So it's these 3 guys here. So from origin plus 3 plus 2 plus 2, and these guys in total is 7 bytes. Okay, because it's in bytes. So if we're adding 7 bytes to origin, so the origin is 4000 plus $, 4007. If we add that up, that's going to equal to $4007. Okay, if it was like 10 or 12 or something like that, we would add A, B, C, D, E, F, or something like that. If it's greater than 10, we follow the hex table. Okay, so now when we do jump subroutine, we added up everything, and now we have 4007, and we're going to put 4007 into the stack content. Okay, and then the rightmost byte goes in. So each 2 digits is 1 byte in hex. So these 2 digits, 0 and 7, is 1 byte, and that's the rightmost byte. So it's going to go into the stack content. 0, 7. And then the left one is going to go in after that, so 4, 0. Okay. So now after this jump to subroutine, and we put in the origin plus all the bytes, put that in there. We're actually going to go into the actual subroutine mel. So mel has push A. So what's in A? $32, which was here. This guy right here. Okay. So now we're just going to push that in. So it comes in from the top again. So $32, and that's the question.